Hello everyone, welcome to our new video. Today we will study about pumps. A pump is a mechanical device which uses suction or pressure to raise or move liquids. The two types of pumps behave very differently regarding pressure head and flow rate. The centrifugal pump has varying flow depending on the system pressure or head. The positive displacement pump has more or less a constant flow regardless of the system pressure or head. We will first study about centrifugal pump. Centrifugal pumps are used to transport fluids by the conversion of rotational kinetic energy to the hydrodynamic energy of the fluid flow. The rotational energy typically comes from an engine or electric motor. Let us now study about the parts of centrifugal pump. The first one is impeller. Impeller is a rotor used to increase the kinetic energy of the flow. The second one is casing. The outer covering of the pump is called casing. The casing contains the liquid and acts as a pressure containment vessel that directs the flow of liquid in and out of the centrifugal pump. It also protects the pump. The next one is shaft. The impeller is mounted on a shaft so that when the shaft rotates, the impeller also rotates with the shaft. Shaft is a mechanical component for transmitting torque. It is also called rotor. The next component is shaft sealing. Centrifugal pumps are provided with packing rings or mechanical seal which helps prevent the leakage of the pumped liquid. The last one is bearings. Bearings are provided between the shaft and impeller to reduce friction between the rotating shaft and the stator. Now, as you can see in this video, the water enters the pump from the eye of impeller. Now the impeller is connected to a shaft and shaft is connected to a motor. So whenever the shaft rotates, the impeller also rotates with the shaft. Now along with shaft and impeller, the water also rotates. Now from rotating, the kinetic energy of water increases. At the exit, what happens is that we convert this kinetic energy of water into pressure energy and then we displace the water outside. This is the main principle involved. I hope that's clear. Next, we will study about positive displacement pump. Positive displacement or fixed displacement means they pump a constant amount of fluid for each revolution. A positive displacement pump makes the fluid move by trapping a fixed amount and forcing or displacing that trapped volume into the discharge pipe. Some positive displacement pumps use an expanding cavity on the suction side and a decreasing cavity on the discharge side. The types of positive displacement pump are gear pump, lobe pump, vane pump, and screw pump. First, we will study about gear pump. A gear pump uses the meshing of gears to pump fluid by displacement. They are one of the most common types of pumps for hydraulic fluid power applications. There are two main variations: external gear pumps, which use two external spur gears, and internal gear pumps, which use an external and an internal spur gears. Internal spur gear teeth face inwards. Some gear pumps are designed to function as either a motor or a pump. So water gets trapped between the teeth of the gear and the gear displaces the water to the outlet through the inner valve of the casing. Next is lobe pumps. Lobe pumps are similar to the external gear pumps in operation in that fluid flow around the interior of the casing. As the lobes come out of the mesh, they create an expanding volume on the inlet side of the pump. Material to be pumped flows into this cavity. The water flows to the inlet and then the outer valve of the casing and then to the outlet. Next, we have vane pump. A rotary vane pump is a positive displacement pump that consists of vanes mounted to a rotor that rotates inside of a cavity. In some cases, these vanes can have variable length and RB tension to maintain contact with the walls as the pump rotates. Let's see the working of vane pump. The simplest vane pump consists of a circular rotor rotating inside of a larger circular cavity. The centers of the two circles are offset, causing eccentricity. Vanes are allowed to slide into and out of the rotor and seal on all edges, creating vane chambers that do the pumping work. On the intake side of the pump, the vane chambers are increasing in volume. Inlet pressure is actually the pressure from the system being pumped, often just the atmosphere. On the discharge side of the pump, the vane chambers are decreasing in volume, forcing fluid out of the pump. The action of the vane drives out of the same volume of fluid with each rotation. So this was our main working principle. Now next is screw pump. A screw pump is the type of positive displacement pump that uses two or more screws that intermesh to pressurize fluids and move them in a system. The screws take in fluid and then push it out from the other side while increasing its pressure. When the water enters through the inlet, it gets trapped in the spaces between the two threads of the screws. Now when these screws start rotating, the water moves towards the outside, that is, it is displaced outside. So that's it for today's video. If you liked it, please like, comment and subscribe to Bunker Study Point. Thank you for watching.